Everything you were taught about our solar system in middle school astronomy class is a polite, sanitized lie. We've all seen the classic poster hanging on the classroom wall. A big, bright yellow sun on the left, followed by 8 neat, orderly planets spinning like clockwork, a tidy belt of dusty rocks between Mars and Jupiter, and cold, empty darkness beyond. It looks clean, it looks predictable, it looks safe, except nature doesn't give a damn about our neat textbooks. Right now, floating through the dark, there is an object made entirely of raw planetary core metal, a multi-trillion-dollar ghost of a murdered world. There is a moon smaller than the United Kingdom that is actively spraying a warm, carbonated ocean into space, carrying the exact chemical recipe for alien life. There's a tiny rock that shouldn't even have enough gravity to hold an atmosphere, yet somehow sports a double system of Saturn-like rings. And orbiting backward around Neptune is a doomed giant monster that is slowly being torn apart by its own parent planet. 4 worlds, 4 cosmic outlaws that actively break our models of physics, planetary formation, and celestial mechanics. Today we are taking a journey to the weirdest corners of our cosmic backyard to see why what we find there is completely rewriting everything we thought we knew about our universe. To understand why these 4 objects are causing cosmologists and planetary scientists to pull their hair out, we first have to talk about how we thought the solar system was made. The standard story goes something like this. About 4.6 billion years ago, a massive cloud of hydrogen gas and cosmic dust collapsed under its own weight. At the center, the vast majority of that mass squished together to spark nuclear fusion, giving birth to our sun. Whatever leftover crumbs were swirling around in the protoplanetary disk began to clump together through a process called accretion. Close to the sun, where it was blistering hot, only rock and metal could stay solid. That's how we got the inner rocky planets, Mercury, Venus, Earth, and Mars. Further out, past what astronomers call the frost line, it was cold enough for volatile compounds like water, ammonia, and methane to freeze solid. That allowed planet seeds to grow massively huge, sucking up thousands of times their weight in hydrogen and helium to form the gas giants: Jupiter, Saturn, Uranus, and Neptune. It's a beautiful, elegant narrative. Everything has its place. Rocks inside, gas giants outside, clean orbits, smooth machinery. Except when planetary geologists started looking really closely at the small stuff, the asteroids, the weird moons, the icy centaurs, the whole neat picture fell completely apart. The early solar system wasn't an assembly line, it was a cosmic demolition derby. Thousands of protoplanets were smashed into oblivion, swallowed by gas giants, or violently flung into deep space like unwanted toys. Most of those fragments disappeared into the sun or disintegrated into cosmic dust. But a few survived, and the 4 objects we are looking at today are the ultimate survivors. Time capsules from a period when the solar system was a total war zone. Let's start our journey in the main asteroid belt, floating in the vast gulf between Mars and Jupiter. Most asteroids in this region are pretty underwhelming. They're basically cosmic trash, rubble piles of loose rock, carbon-rich gravel, and dirty ice held together by weak gravity. If you've seen one rocky asteroid, you've pretty much seen them all. And then there's 16 Psyche. Discovered back in 1852 by Italian astronomer Annibale de Gasparis, Psyche spans about 220 kilometers across, roughly the size of Massachusetts or the entire country of Wales. For over a century, astronomers just assumed it was another big rock in the belt. But when modern space telescopes, radar imaging, and infrared spectroscopy finally got a good look at it, scientists realized something was deeply, fundamentally wrong with this object. Psyche isn't made of rock. It's made almost entirely of raw, heavy metal, specifically iron and nickel, along with potential traces of precious metals like gold, platinum, and palladium. To put into perspective how completely absurd that is, try to imagine an object the size of an entire US state that is literally just one continuous, solid chunk of metallic alloy floating in space. If you brought Psyche to Earth, its raw metal value alone would be worth an estimated 10,000 quadrillion dollars. That is more than 100,000 times the entire annual GDP of the global human economy. If every person on Earth got an equal cut, we'd all be multi-billionaires overnight, and the global metal market would instantly collapse. But hey, that's economics for you. But scientists don't care about Psyche's price tag. They care about its birth certificate. Because according to everything we know about how planets form, an object like 16 Psyche should not exist in the asteroid belt. To understand why, let's take a quick look beneath our own feet. Earth has a metallic core made of iron and nickel. We know it's there because of seismic waves, but we can never ever see it or sample it directly. The deepest hole humanity has ever managed to drill, the legendary Kola super deep borehole in Russia, reached a paltry 12 kilometers into Earth's outer crust before the heat and pressure started melting the drill bits. Earth's metallic core sits trapped under nearly 3,000 kilometers of scorching hot rock mantle. The pressure down there is over 3 million times atmospheric pressure, and the temperature rivals the surface of the sun. So how on earth do you end up with a giant ball of pure planetary iron floating completely naked in the vacuum of space? There is only one leading scientific explanation. Psyche is the exposed heart of a dead protoplanet. Psyche was on its way to becoming a full-fledged terrestrial planet, perhaps as large as Mars. As it grew, it underwent a process called differentiation. The heavy, dense elements, iron and nickel, sank to the absolute center to form a hot metallic core, while the lighter silicates floated to the top to create a rocky mantle and crust. But just as Psyche was settling into its young life, disaster struck. During the chaotic demolition derby of the early solar system, Psyche suffered a catastrophic series of hit-and-run collisions. A giant protoplanet, or maybe multiple massive objects, struck Psyche at hypersonic speeds. The impacts were so violent that they didn't just crack the planet. They literally peeled away its entire rocky mantle and crust, blasting billions of tons of rock into deep space. The outer layers were erased, halting the planet's growth forever and leaving its hot liquid iron core freezing in the void. Psyche is a zombie world, a planet that was murdered before it ever got a chance to be born. In October 2023, NASA launched the Psyche mission, a dedicated spacecraft riding a Falcon Heavy rocket designed to travel 3.5 billion kilometers to get a first-hand look at this metallic monstrosity. The spacecraft recently completed a successful gravity assist maneuver around Mars, using the red planet's gravity to catapult itself toward the asteroid belt. When Psyche arrives at its target in 2029, it will mark the first time humanity has ever visited a world that isn't made of rock or ice. What does metallic geology even look like? Do impact craters on a metal asteroid leave bent, twisted iron rims instead of pulverized dust? Are there frozen iron-sulfur lava rivers that once erupted from its cooling interior? Does it have a remnant magnetic field trapped in its metallic skin? But when Psyche finally sends back its high-resolution images, we won't just be looking at an asteroid. We will be looking at what Earth's own core looks like, giving us a direct window into the center of our own home planet without ever having to drill a single inch into the dirt. If Psyche is a terrifying lesson in how planets die, our second cosmic outlaw is a lesson in where alien life might be thriving right now. Let's head out past the frost line, past the asteroid belt, to the majestic gas giant Saturn. Saturn is famous for its gorgeous, sweeping rings and its giant Titan moon, Titan, which has methane lakes and a thick orange atmosphere. But if you ask astrobiologists where the most exciting place in the entire solar system is, they won't say Titan, Mars, or Europa. They will point you to a tiny, unassuming white pearl orbiting Saturn called Enceladus. At first glance, Enceladus looks like a complete lightweight. It's tiny, just 500 kilometers in diameter. You could comfortably fit the entire moon inside the borders of the United Kingdom, or fit it easily between Los Angeles and San Francisco. Because Enceladus is so small, and because it sits nearly 1.4 billion kilometers away from the Sun, where temperatures hover around a bone-chilling minus 200 degrees Celsius, basic physics says it should be dead. A tiny world like Enceladus doesn't have enough radioactive decay in its core to stay warm. It should have frozen solid down to its center billions of years ago. A dead, silent ball of ice. On top of that, Enceladus is the most reflective object in the entire solar system. Its surface is covered in fresh, clean water ice that acts like a cosmic mirror, reflecting nearly 100% of the tiny amount of sunlight that reaches it. It should be a frozen desert. Except in 2005, NASA's Cassini spacecraft flew close to Enceladus's south pole and caught the moon committing a massive act of cosmic vandalism. Cassini's cameras captured giant plumes of vapor shooting out of Enceladus's south pole, blasting water ice hundreds of kilometers straight into deep space. Scientists were floored. The ice wasn't just sublimating, it was actively erupting. Enceladus had giant cryovolcanoes, ice geysers, blasting out of 4 massive parallel fractures in the frozen surface, affectionately nicknamed the Tiger Stripes. Subsequent measurements confirmed something mind-boggling. Beneath an outer shell of ice, roughly 20 to 30 kilometers thick, Enceladus holds a global liquid water ocean. Think about how wild that is. A tiny moon, hundreds of millions of miles past the Sun's habitable zone, is holding onto an ocean that contains more liquid water than the total volume of many of Earth's seas. Where's the heat coming from? The answer is gravity. Enceladus orbits Saturn in a slightly oval, eccentric path, caught in a gravitational tug-of-war between Saturn's immense pull and a neighboring moon, Dione. As Enceladus swings closer and further from Saturn, the giant planet's gravity constantly squeezes and stretches the moon's core like a stress ball. That internal friction generates immense heat, keeping the deep ocean liquid and preventing the moon from freezing solid. Now, an underground ocean is cool, but is there anything living in it? Here's where Enceladus pulled off its ultimate magic trick. Instead of having to design a complex, multi-billion-dollar mission to land on the surface, build a nuclear laser drill, melt through 20 kilometers of solid ice, and drop a submarine into the dark depths, which is what we'll have to do on Jupiter's moon Europa, Enceladus is voluntarily shooting its ocean water directly into space for us to taste. The engineers at NASA realized Cassini was on a trajectory that allowed them to do something insane. They commanded the spacecraft to lower its orbit and fly directly through the erupting geysers at thousands of miles per hour. Cassini's onboard mass spectrometers sampled the fresh ice particles and gases spraying from the interior ocean. And what it found set the scientific community on fire. The geysers didn't just contain pure water. They contained complex organic molecules, methane, carbon dioxide, salts, ammonia, and molecular hydrogen. Finding molecular hydrogen was a massive smoking gun. On Earth, free hydrogen in ocean water only comes from one specific source: hydrothermal vents. Deep on Earth's ocean floors, superheated, mineral-rich water shoots out of volcanic vents called black smokers. Bacteria and hydrothermal organisms feed on that chemistry, creating entire flourishing ecosystems in complete darkness, completely independent of sunlight. And then, in 2023, scientists analyzing archived Cassini data found the final missing piece of the puzzle: phosphorus. Phosphorus is the rarest and most critical of the 6 fundamental chemical elements required for all terrestrial life. carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, known by the acronym CHNOPS. Phosphorus is the structural backbone of DNA, RNA, and ATP, the energy molecule that powers every cell in your body. Before this discovery, scientists weren't sure if extraterrestrial oceans would have enough phosphorus to allow complex biochemistry to kick off. But the data from Enceladus showed phosphorus concentrations in its subsurface ocean that are hundreds of times higher than in Earth's oceans. Let's spell this out clearly. On Enceladus right now, we have a stable, long-lasting liquid water ocean, an abundant thermal energy source powering hydrothermal vents on the ocean floor, the complete, unbroken set of CHNOPS organic building blocks. Enceladus is no longer just a cool moon. It is officially the single most habitable place in the entire solar system outside of Earth. If life can start spontaneously anywhere the conditions are right, there could be alien hydrothermal ecosystems swimming beneath the ice of Enceladus at this very moment. And the best part? We don't even need to dig to find them. The next dedicated mission to Enceladus will simply fly through those glorious geysers with modern, state-of-the-art instruments, scoop up the icy mist, and search directly for alien biomarkers. Leaving the warm, carbonated seas of Enceladus behind, we push even deeper into the freezing twilight of the outer solar system, past the orbit of Saturn, out into the vast, lonely void before you reach Uranus. Here, drifting through the dark, you'll find a bizarre class of minor bodies known as centaurs. Centaurs are cosmic shapeshifters. They aren't quite standard asteroids, and they aren't quite comets either. Their orbits are wildly unstable, constantly getting tugged, pulled, and slingshotted around by the gravitational muscle of gas giants like Jupiter, Saturn, Uranus, and Neptune. Because of these chaotic orbits, centaurs don't stay in one place for long. Cosmologically speaking, they are on a fast track to either getting flung out of the solar system entirely or plunging headfirst into a giant planet. And among these unstable outlaws sits a tiny, dark rock named 10,199 Chariklo. Discovered in 1997, Chariklo is small, measuring roughly 250 kilometers across. That's about the distance from London to Paris. It's an irregular, cratered chunk of dark rock and ice. By all standard rules of planetary science, Chariklo should have been just another boring footnote in space catalogs. To understand why Chariklo suddenly became one of the most famous small bodies in astronomy, we have to talk about a golden rule of physics that scientists held as gospel for over 300 years. You need massive gravity to hold on to rings. Think about every ringed world we've ever discovered. Saturn is the undisputed king of rings, but Jupiter, Uranus, and Neptune have ring systems too. What do all four of these worlds have in common? They are absolute behemoths. They have massive gravitational wells capable of holding on to billions of icy particles, herding them into clean, stable disks, and protecting them from getting scattered into deep space by solar radiation or gravitational tugs from other planets. If you had asked an astrophysicist in 2012 whether a tiny 250-kilometer asteroid could have rings, they would have laughed in your face. A tiny body like Chariklo has such weak gravity that solar wind and simple orbital dynamics should disperse a ring disk in a microscopic fraction of cosmic time. Then came the night of June 3rd, 2013. Astronomers pointed a fleet of powerful ground-based telescopes across South America toward Chariklo to observe a rare event called a stellar occultation. The concept is simple. As Chariklo moved across the night sky, it was scheduled to pass directly in front of a faint distant star. By measuring the exact split second the star's light blinked out behind the asteroid, scientists could calculate Chariklo's precise size, shape, and shadow. The event started, the telescopes recorded the data, and when scientists looked at the light curve, their jaws collectively dropped. The star's light didn't just blink out once when Chariklo passed in front of it. A few seconds before Chariklo blocked the star's brightness suddenly dipped twice in quick succession. Then Chariklo passed, blocking the star completely. And then, a few seconds after Chariklo moved out of the way, the star's brightness dipped twice again in the exact same pattern. The conclusion was undeniable, incredible, and completely insane. Chariklo wasn't alone. It was surrounded by a double system of dense, sharply defined rings. Let that sink in. A rock so small you could drive across it in 3 hours is wearing its own personal mini Saturn crown. Astronomers named the two rings Oiapoque and Chuy, after two rivers near the northern and southern tips of Brazil. The inner ring, Oiapoque, is about 7 kilometers wide. The outer ring, Chuy, is about 3 kilometers wide. They are separated by a razor-thin 9-kilometer gap of empty space. And it gets even cooler. In 2023, the James Webb Space Telescope trained its powerful near-infrared instruments on Chariklo during another stellar occultation. JWST didn't just reconfirm the rings, its ultra-sensitive spectrographs detected clear spectral signatures of crystalline water ice inside those rings. So how on earth does a tiny cosmic potato maintain two perfect frozen rings without them flying apart into the void? The leading scientific theory is that Chariklo isn't working alone. It likely has tiny yet undiscovered shepherd moons, microscopic satellites, maybe just a few hundred meters wide, orbiting within or right beside the rings. Just like Saturn's shepherd moons, Pan and Daphnis, these tiny moons use their localized gravity to constantly herd the ice particles, kicking loose particles back into line and keeping the edges of the rings razor sharp. Chariklo completely shattered our arrogance about how ring systems form. It proved that rings aren't an exclusive VIP perk reserved for giant gas planets. Even the smallest, most forgotten outlaws drifting through the deep freeze can build their own cosmic jewelry. For our final outlaw, we have to travel all the way to the absolute edge of the planetary solar system, 4.5 billion kilometers from Earth, to the deep, dark blue gas giant Neptune. Neptune has 16 known moons, but one of them dominates the entire system like a leviathan among minnows. That moon is Triton. Triton is massive. At over 2,700 kilometers in diameter, it accounts for more than 99.5% of all the mass orbiting Neptune. It is larger than the dwarf planet Pluto, larger than Eris, and nearly as big as Earth's own moon. When NASA's Voyager 2 probe made its historic flyby of Neptune in August 1989, it sent back the first close-up images of Triton. What scientists saw was a world that looked completely alien, a pale, pinkish-blue ball covered in strange, wrinkly terrain that resembled the skin of a cantaloupe melon, dotted with vast plains of frozen nitrogen and icy cliffs. But it wasn't Triton's looks that terrified planetary dynamicists. It was its orbit. Every single major moon in the solar system, our moon, the Galilean moons of Jupiter, Saturn's massive moons, orbits its host planet in a prograde direction. That means they swing around their planet in the exact same direction the planet itself is spinning. This happens because those moons originally formed out of the same spinning pancake of dust and gas that created the main planet billions of years ago. Triton doesn't do that. Triton orbits Neptune backward. Triton is the only large moon in the entire solar system with a retrograde orbit. It spins clockwise while Neptune rotates counterclockwise. On top of that, its orbit is tilted at a bizarre 23-degree angle compared to Neptune's equator. This single orbital anomaly tells scientists a dark, violent story about Triton's past. Triton was not born around Neptune. Millions of years ago, Triton was an independent dwarf planet, a sovereign king of the Kuiper Belt, much like Pluto, floating freely through the outer dark with its own moons. But one day, Triton wandered just a little too close to Neptune's massive gravitational field. In a violent cosmic hijacking, Neptune's immense gravity snatched Triton out of deep space and dragged it into orbit. As Triton was pulled into this new, backward path, its massive gravitational weight threw Neptune's original system of native moons into utter chaos. Triton's gravity likely smashed Neptune's original inner moons into each other, grinding them into dust or flinging them out into intergalactic space. Triton wiped out an entire planetary family to claim its throne. And yet, despite being a stolen world sitting in a deep freeze at minus 235 degrees Celsius, making it one of the coldest places ever measured in the entire cosmos, Triton is aggressively, shockingly alive. When Voyager 2 flew past Triton's south pole, it captured images that left geologists speechless. Giant cryovolcanoes shooting plumes of black dust and liquid nitrogen 8 kilometers straight up into space. High-altitude winds in Triton's thin nitrogen atmosphere caught those volcanic plumes, streaking long, dark trails across the pale ice plains below. Triton is powered by internal heating, likely caused by the intense tidal flexing it suffered as Neptune violently wrestled its backward orbit into a circle over billions of years. Triton is a living, breathing Kuiper Belt planet, preserved in a deep freeze orbit around a gas giant. It gives us a direct, active look at what Pluto and other distant dwarf worlds look like under extreme gravitational stress. But this epic story doesn't have a happy ending. In fact, Triton is living on borrowed time. Because Triton orbits Neptune in reverse, it is trapped in a fatal gravitational feedback loop. As it swings around Neptune, its gravity creates a tidal bulge in Neptune's atmosphere that lags slightly behind the Moon. That bulge constantly pulls back on Triton, acting like an invisible, relentless set of cosmic brakes. Every single day, Triton loses a tiny bit of orbital energy. Every single year, its orbit decays, dragging it closer and closer to Neptune's clouds. Right now, Triton is slowly spiral falling toward its master. And in about 1.4 to 2 billion years, Triton will cross a point of no return known as the Roche limit. The Roche limit is the exact distance where a planet's tidal forces become stronger than the internal gravity holding a moon together. When Triton crosses that line, Neptune's gravity will literally grip the moon and rip it apart from the inside out. Triton won't crash into Neptune. Instead, over the span of a few horrifying weeks, over 21 trillion tons of frozen nitrogen, rock, and water ice will be shattered into a swirling storm of billions of icy boulders. Those fragments will spread out around Neptune's equator, giving the blue gas giant a massive, glowing, brilliant ring system that will make Saturn's rings look like a faint toy. Triton is a condemned world, a captured monster marching slowly toward its own magnificent, violent execution. When you stand back and look at the solar system through the lens of school textbooks, it feels quiet, neat, and complete. It's easy to fall into the trap of thinking that space is an orderly, finished machine where everything sits comfortably in its proper place. But worlds like 16 Psyche, Enceladus, 10,199 Chariklo, and Triton prove that reality is infinitely more chaotic, unpredictable, and beautiful than our simple models. 16 Psyche proves that for every fully formed planet we see, there are dead, metallic ghosts of worlds that were murdered in the cosmic dark. Enceladus shows us that life doesn't need a cozy Goldilocks zone or warm sunlight. It just needs a little gravity, water, and the right chemical recipe bubbling in the dark. Chariklo reminds us to stay humble, showing that even a tiny, forgotten space rock can break 3 centuries of physics rules and wear a ringed crown. And Triton serves as a dramatic, beautiful reminder that orbits are not forever, and that the worlds we see today are just a temporary snapshot in an endless cycle of destruction and rebirth. Our cosmic backyard isn't a static museum. It's a dynamic, evolving, violent frontier, and we have only just begun to read the stories written on its strange outlaw worlds. Thank you so much for watching. Which of these 4 outlaws blew your mind the most? Let me know in the comments below. I read and reply to as many as I can. Thanks for watching, stay curious, and I'll see you in the next one. Bye.